right, you guys, I got Zoe, my daughter, helping me out with videotaping. Thank you, Zoe. If you had physical science with me last year, then you remember when she held and volunteered her phone and we broke the phone. So it's fine. Okay, here's my mistake. Cohort A, I should have sent you guys home with this new packet today, and I totally forgot to do that with you guys. So you've got options. I do have it there as it's under the reference material. You can print it off yourself and go ahead and go through it. It's about 5 pages if you print it front back. Otherwise, just know, we'll get this handed out to you next time you're in class, and this is a lesson you still have to do. And I'm sorry, I totally just dropped the ball with remembering to hand this out. So we are in the note packet. We're in a new note packet. So this is BP2 note packet, and we're learning about crystals, which is why you guys are starting to grow them, which they're really looking good. I got to see some of them. And why do we care about crystals? What's the difference between different types of crystals? And how do they grow? How does the crystal arrangement impact the type of material that we actually use? So it's quite fascinating. If you don't know crystals, then you will never understand concrete or polymers or metals or alloys or anything like that. So step 1 is just to understand crystals. So we are going to fill in some notes between pages 1 and 2, and then I have some video demos that I'm going to show you. Normally I would show you as an actual demo, but this year it's going to be in the form of a video, which is awesome. So crystals. Okay, why do we even care about these crystals? And the real reason, or one of the big reasons why we care, is because the structure of them will help us understand the properties of that material. So the structure kind of dictates properties. And as I was researching this particular segment and deciding what I wanted to show you guys, I ran across this video, which I find quite fascinating. Zoe, whenever we do this, as best as you could just zoom in and then hopefully hold your hands still while Okay, so really fascinating, huge crystals. If you caught all of that video, imagine what you guys are growing in the back of the lab, and what if we were able to grow crystals that large. So there's a place here on the earth that does that. So when we think about crystals, there's a few different ways that we can actually make crystals, make solids form, and that's what we're gonna get in our notes right now. I've replaced some of these demos with just videos of it. So one way that we can get crystals to form is and it's really all from solutions, but from solutions we can do what's called a precipitation reaction. So if you were in any type of chemistry class, you learned about single replacement reactions, double replacement reactions. Those produce precipitation. I'm just going to show you some examples of that. Zoe, are we able to, can we see this good enough? I'm going to turn the lights out because we're just going to watch
No, it's good.
It's okay, all right. So this is a test tube of 2 different solutions. Ooh, that is kind of hard to see though, isn't it?
Now it is.
And they're going to mix the 2 solutions. One is a sodium chloride solution right here.
That's fine now.
It's good? All right, I can do this real quick. And it's mixed with, so the silver chloride was clear, the sodium chloride solution was clear, but whenever we mix it, we get this white precipitant. So this truly is a crystal, okay? It doesn't look like some real pretty crystal, but it was a crystal that was formed, and that white precipitant is silver chloride. So, any solid is a crystal. So that's one way that we can get it. So we can do it by precipitation reactions, whether it's single replacement reactions or some other type. Another way that we could form crystals, still from solution, is supersaturated solutions. That's what you guys are actually doing right now in the back lab. Whenever you first got your blue crystals or your purple, whatever they might be, the clear ones, they began to crystallize. Now we are putting them in a supersaturated solution, and more crystal is going to be produced on that bigger crystal that's in that solution. So another example of a supersaturated solution are hand warmers. And not all hand warmers are like this, but the kind of hand warmer that you would take and you would actually break it to get it to work, that crystallizes In fact, I'll see if I can find one real quick while Zoe, I don't know if I have it working, but we'll let you watch this video. This is the same stuff that's in a hand warmer, but it ends up making a super saturated solution just from liquid. So I'll let you watch this. Let me see if I can find my hand warmer. I don't know if I can. So it was a liquid, and it is crystallizing very, very quickly. Did he already pour it onto the solution, or is it, he might still do that? Yeah. And I think, let's see, just keep watching. So this solution is, again, it's called super saturated. It really holds more in there than what it should be able to. And sodium acetate's really strange with how this happens. Normally this is a demo I do with you guys around, and if you were to have your hands near it, it would feel warm. So it's coming out as a liquid, but it really doesn't want to hold all of that solution, all of the sodium acetate in the water. So when I say solution, it's sodium acetate dissolved in water. And it's very unstable to the point of just a little bit of agitation would create this to happen, or we can turn it into a solid. So I already activated this one, but this is what I mean by a hand warmer. It started off as a liquid, and there's this little disc in here, and I would agitate that disc and it would immediately crystallize right here. So this is a super saturated solution that's making a crystal, okay? A third way that we could form crystals is just by changing states of matter. That's what these last two are going to be. So deposition is a gas going directly into a solid. When you think about frost forming on your windshield in the wintertime, that's deposition. The ice that forms on the sides of a freezer, that's deposition. So here's just a fun little video of, and I'm not going to play the sound, but of different snowflakes. So we all know that not all snowflakes are the same. These are just showing, now that one's melting, but I think we can go through a couple of videos of just, again, deposition. So somehow that snow is forming up in the sky, and then as it forms, it's making all these beautiful snowflakes that we end up seeing. So deposition going from a gas to a solid forming. And you can do this a variety of different ways. And I'm not going to force you guys to watch all of this. And then the last would just be another state of matter change, and it's just liquid going to solid. So freezing would be our fourth and final way we can get crystals to form. And whenever we think freezing, we tend to always think, oh yeah, water freezes. But you need to realize that, you know, anything can freeze. Anything can go through any state of matter. So I have a video, and normally, again, I do this with you guys, but you know, sulfur is normally a solid at room temperature, but we can get it to liquefy pretty easily. And once it goes back to a solid, you can really see some pretty cool crystal structures forming. So this is sulfur that has already been heated, and it's in a liquid state at this point. And I think I just clicked out of it. And as it begins to cool, you're going to see the crystallization happening again. So we've taken sulfur that's a solid room temperature, we've melted it. This is liquid sulfur, and then it's going to begin to cool again, and you're going to see crystallization happening as it cools. And you can already start to see it forming right here. And it looks like a crystal as it grows. It has a crystal-like appearance to it. Let's see if we can get a little bit close. Yep, and you can, again, those are called dendrites. We'll learn later that these have the name dendrite, but this is crystallization that is occurring as that sulfur just freezes. It's just freezing. And we don't think of sulfur as being something that crystallizes like that, but it is. Okay, so the big takeaway here is I don't want you to think that the only things that are crystals are the things that make this big, beautiful, snowflakey type of shape. We think of water as forming crystals, but really all solids form some type of a crystal. We are going to talk about amorphous solids, amorphous crystals, but really amorphous solids eventually. But sulfurs can crystallize, nickel crystallizes, iron crystallizes, and in that crystal structure, they all are going to behave a little bit differently. So to me, this is a fascinating unit. It's so fun to get to grow these crystals. You guys are going to be starting growing some copper crystals pretty soon, and looking at that. It's a pretty cool thing to get to investigate. So sorry, Cohort A, I forgot to get this out to you. So you might be doing this a little bit later in the week, or you printed it up already. Cohort B, you're going to be getting this tomorrow, so you should be good to go, I think. All right. Cut her off.